Hi, I'm Sarah Gerbauer. I'm a physician and informaticist and the creator of Machine Learning for MDs. This is Medical AI for Busy Doctors, crucial concepts in less than 10 minutes. Today, the concept we'll be discussing is the development of AI models and what doctors need to know about the decisions and the trade-offs inherent in building any computer model. Specifically, we'll be talking about machine learning models. The general idea of designing a machine learning model is very similar to designing a clinical trial or a study that you have seen a million times. You define the population, define your metrics, define your data, then you format your data, develop a draft model, which is similar to a pilot study, and then you refine it. So this process is something you intuitively understand and are familiar with. Of course, there are many decisions that go into any model, and these are just some of the major topics. The first thing we'll talk about is the model architecture. Some aspects of model architecture are determined by the type of data and tasks you have. So images will be handled by a different approach than weather predictions or text, for example. There are also decisions about supervised versus unsupervised learning that are determined by what you're trying to do, and a decision about whether to use human reinforcement of the learning. As you can see, a lot of these decisions will be dictated by the type of data you have and what you want to do with it. Along with the understanding of how studies are designed comes the knowledge that whenever you design a study, or really whenever you build anything, whether it's a model or a table or a luxury high-rise, there will be some trade-offs involved because more complex models are more accurate, but also harder to understand and to explain. For medical issues, it's often more important than in other fields to be able to explain where a recommendation or prediction came from. Unfortunately, the more accurate models are generally harder to explain. The more complex your model, the more it's going to have a black box component to it. You can see that there are some types of models that are less accurate but easier to explain, like linear regression and decision trees. And then some that are more accurate and harder to explain, like neural nets. Adding more layers to your model will also usually make it more accurate but harder to explain. More layers also mean that the models take longer and need to run on computers with large amounts of processing power, which can also be expensive. These complex models are also more prone to hallucinations, just making stuff up, and to reflecting bias in its input data. These issues are more disturbing in medicine than they would be in, say, a report about car sales. Next, there's a fundamental trade-off between performance and things like processing power, cost, and time. These three aspects are often directly proportional. So if the processing power increases, your cost will also increase, as well as the time it takes to run. Performance improves with more data. That's not a surprise, but it does seem to make a bigger difference with deep learning models than with other AI or machine learning algorithms, in terms of how much data you have and how much the performance increases. At some point, though, you're going to reach a point where more data is not necessarily going to get you a better answer, though that's likely to be a very large amount of data. These large data sets are hard to get, they're expensive, and once you have them, they take more processing power, which is also expensive. So in summary, the more complex the model and the more data you have, the better it will likely perform. But that will also make it harder to understand and explain, and make it cost more. Thanks for joining me today, and I look forward to seeing